Hello everyone, welcome back to my YouTube channel. Today we're going to be doing a practical on how to test an induction motor using a multimeter. On the induction motor, you've got the main housing, as you can see on the video, which consists of a drive shaft, and we have a frame or enclosure which has the fins, and we have a motor feet or base, a terminal box, and then we have a fan cover or end bracket, and then we have our multimeter which we'll be using, and it's a 177 fluke meter. We'll be using these leads or probes for our testing. The induction motor has been in operation for over 100 years. It was invented by one of the greatest scientists, which is Nikola Tesla. That's the basic for our practical today. The inner housing consists of two main parts, which is the stator and the rotor. Since this is a three-phase motor, we have 3 windings. And the first thing that is very important to also notice, to also inspect your nameplate before you do anything on your motor or testings. This is a ACW motor, and it's a brand new motor. You've got also a manual inside, which you can also refer to with some of the things that are not on your nameplate, especially those finer details about the motor, which can include also the torque and the operational temperature. This motor came from the shop wired in a star connection. You can check on my previous videos on how to wire a star or delta connection and how to program those connections, or how to program a star delta starter. On our terminal box, we've got our primary and a secondary side, which on your secondary side you'll find your U2, V2, W2. Step 1 is your mechanical inspection, which is your drive shaft. It goes together with your visual inspection, which is just to check if anything is blown or there's something smelling or there's something stuck. So usually just remove your cover, and then you will turn your shaft just to check if the bearing hasn't seized, but it takes a long time for a bearing to seize, so it should move freely. When you turn your shaft or when you turn your fan, either of the two should move. You've got 2 bearings inside there, so those bearings sometimes they seize, but they usually take time, and you'll see when they are seizing. So the first thing is to just rotate your shaft or your fan, and you also just visually inspect if there's nothing blocking, or you just pull it to check if it's not wobbling around. The fan plays a critical role on an induction motor because they tend to overheat a lot. So as the fan is turning, the cover pushes the air to the fins, and the fins increases the surface area to remove the heat inside your windings. Because if it overheats, then you'll be in trouble, because you might have a short circuit, or you might have down to earth, because the insulation inside your windings will be damaged. Even the bearings, they have their own operational temperature, so you don't want your motor to overheat. That's why we have the fan for cooling purposes. We have red, blue, black on our primary side, and we have white, yellow and brown on our secondary side of the windings. Please like and subscribe for more videos. My first test will be practical test, like if you are in the plant and you can access the motor easily, so you are checking from the panel side to test your motor. Second step, we'll be taking our meter, and then the first thing you do, you put your meter into continuity, but I usually like to work with ohms because continuity on my meter only starts toning at less than 40 ohms. As you can see, it's showing 1 ohm right now. The difference between measuring in ohms and continuity is that when you're measuring in ohms, you are measuring the electrical resistance, and then in continuity you are measuring, or it shows you the indication of open or a closed circuit. As you can see by just checking my leads on the video, this is the ohms we are reading. So we'll start with just checking the frame of the motor just to confirm our meter readings. Remember, the terminals inside, they are not connected to the frame, so you should just charge the frame. We'll confirm the motor shield by continuity. Now we put our meter to ohms, then you can see the difference between measuring with ohms and measuring using continuity. So we'll just confirm by testing the whole main housing. As you can see, all the ohms are almost the same. It's just the paint which make our leads to not connect properly on some of the spots. The first test that you will do when you are testing on your panel side, because you'll be having 4 wires, which is your earth and your 3 windings or your phases, live 1, live 2 and live 3. So what you'll need to do is to put one of your lead to earth. In this instance, it will be our frame, but on your panel side you'll be having 4 wires, and then you check with each of your windings on your panel side. Remember, we are still doing the panel side, not when you are dealing with the motor at the workshop, because this motor is connected in star, which means your windings are shorted on one side. Now we go to a second test that you can do. Remember, this is a quick test on your panel side where you have only 4 wires from your motor. So the second test that you can do is the winding resistance test. So remember, on your 3-phase motor, your windings resistance should be almost be equal or should be balanced. So now you are checking the imbalance of the winding. Others, they call it a continuity test. So as you can see, we are checking in between the 2 winding, which is V1 and U1, and V1 and W1 and W1 and U1. So your windings should be balanced. Remember, this is a star connection, so you'll be reading the windings between the star connection, and also because you'll be having a cable, you'll also be reading between the cable, the resistance of the cable. So you are just checking the balance of your phases. So the ohms that you will be getting should be almost be equal, or should be equal, or should be balanced within the 2% tolerance. You can also check the spec on your nameplate. Okay, that was the first phase, which is just a quick testing. Now we are removing the star connection. Now we'll do the second phase, which will be the proper connect testing. Now that one is just a quick testing, like some of us are working in the FMCG industry, fast moving good industry, where you need to think fast or act fast or solve the problem fast. There's no time to go to the workshop and test the motor and everything. You can just test from your panel side. So that was a star connection. Right now I'm just showing you the delta connection on the same motor. That's why we have 3 links. Remember also the resistance. Now you'll see there will be a change in resistance. Remember we are reading 4.8 because we are reading the resistance in between. We are also including the resistance of the links. Same thing when you have also your cable, because you'll be reading from the panel side, you'll also be reading the resistance of the cable. So it's also that testing also help you if there's a short on the cable or the cable is damaged. That's why I always start by testing from the panel side before I go to the motor, because it makes things simple. Now we are going to do a proper testing. Let me just put back the screw so that those wires don't bump, because that can also give you false reading and you'll think your motor is damaged, but it's just you and your leads and your connection. This will be the test when you have taken out your motor to the workshop. The second step of your testing after your mechanical and visual inspection, if you're at the workshop, then is to test your continuity or your winding. So you put your lead on U1 and U2. So you are testing the resistance or the continuity, which is 2.6. You'll also reference from that one of the panel testing, which was 4.6 because of the Starlink. It can be higher if you have also we are testing through the cable. And then you'll also test V1 and V2. The resistance should be balanced. Same thing that we are testing with the fast test or the panel test. You also test W1 and W2. It all tipped 2.6. On the other side it was 4.8 because of the link. So that means your motor windings are healthy. Step number 3 is your earth leakage test or down to earth test. So you put one of your lead to the frame and then you test with each of your windings. You can test on your primary side or you can test on your secondary side, since we have started with testing the continuity test and you are happy with it. Fourth step, you are testing the short. So you are testing any continuity or resistance in between your windings. So you can test from your primary side or you can test from your secondary side. It is up to you how you want to test it. We also call it an insulation test because you usually find this problem when your motor has overheated. So you will find that your windings are shorting inside. So it's one of the tests that you need to check. And remember, with this test now your motor is isolated. You are just testing your motor alone at the workshop. Those are the 4 steps of testing a motor. Step number 1 is your continuity test. Step number 2 is your ground test, which is your at leakage. Step number 3, it is your resistance test, which is your windings. Step number 4 is your short circuit, which is your insulation test. Props mentioned, I forgot to tell you before we started the video that if you are working on the motor, the first thing that you do, you isolate the motor. Even on the panel testing, you must isolate the motor and then you test your wires from the motor, not the wires from your mains, because we don't want to lose more people because of electricity. We know that electricity kills more than 1,000 people every year. So please isolate your circuit before working on it and make sure that your earth is working properly. As you see, I've tested the frame and make sure that nothing is down to earth. If you are reading OL or I, depending on the test that you are using, then your motor is grounded and you should be able to safely test that motor. But the important step is to isolate your motor. Induction motors are widely used, especially in conveyor belts, fans and pump. They consume 50% of worldwide usage of electricity. It's a motor as any other motors. It turns electrical energy into mechanical energy. Inspection label on the motor to find the configuration is one of the most important things to do as a technician or as a person in your household that is having a motor. Every electrical motor should have a label somewhere containing 2 key pieces of information. That is the type of current and the voltage of the motor and the limits and their max and their minimum. Those are some of the critical information that you need to know before you test the motor. Also the winding resistance on the normal condition of the motor, you'll also find it on the nameplate or on the small manual that you'll find inside the junction box or that comes with the box of the motor. On the next video, I'm going to show you how to read the nameplate of the motor. We'll start with reading this one that I was using right here. This is the ACW motor. Please like and subscribe. Most of the people who view my channel, they're not subscribed. Please subscribe and like so that I can keep sharing more content and more experience on my field.